George Percivall. I'm on the staff of OGC, and I get to talk about all the great stuff that our members do, of which there's several here today, so welcome. So let's talk about what OGC is up to in the area of really location. So this was a slide that I presented earlier in the week, but I thought it was pretty relevant, is the power of location. Here we are at Mobile World Congress. There's a lot of commercial activity that's going on. The CEO of WPP, which is the largest marketing firm in the world, somebody named Sir Martin Sorrell. I hadn't heard of him. I'm sure he's famous. If you're a marketing guy, you probably know who he is, right? He's probably a god. So his comment a couple years ago here at Mobile World Congress was, location targeting is a holy grail for marketeers. So having that location is very key to a big segment of part of our customers. Another view on that is from really a science and engineering and statistics perspective, kind of an article that's been quoted by many folks now out of science that involves tens of thousands, maybe hundreds of thousands of CDRs from a mobile urban environment for call data records or cell data records. I'm not quite sure what those are. Every time you turn on your phone, it says hello, and so they know where you're at. And so anonymized CDR records were used, and stochastic analysis was done on it. You get concepts of entropy and the like to be able to make the prediction capabilities. So very much a peer-reviewed article about the power of location. And if it doesn't scare you that people are 93% predictable, it scares me. I like to think myself as a little more unpredictable than that. But so that's an interesting article. Although, for those of us that have been involved in geospatial, and especially the GIS guys, are at this point saying, is this news? Do we, are we surprised that location is important? At this point you're saying, well, where's Waldo, right? Well, Waldo has a special meaning in geography. He is the one that wrote the first law of geography a few years ago that says everything's related to everything, but near things are related more than other things or distance things. So the power of location and doing a lot of different things, it's more powerful, I think, than social graphs. It's probably not as powerful as, in terms of determining intent, as search. Search is probably more indicative of your intent than location, but location is pretty darn predictable about what you're going to do and where you're going to be. So, power of location, we have one slide about that. OGC is all about location and geographic and geospatial information. Our history is in GIS, but it's much broader now with respect to geospatial of any kind, remote sensing, indoor locations, all the varieties that go along with that. We're an organization, not-for-profit, founded in '94. Alliances are a huge part of what we on staff do. Maintaining coordination is one of my regular jobs. The census, two ways to look at it. One is that we're about a third commercial, a third government, and a third academic and research combined. So a really good, healthy mix of the different segments of the industry or the world that are involved, and it really is a healthy activity that way. The other way to look at it is a third in Europe, a third in the US, and a third in the rest of the world. So, if you've heard of OGC in the GIS world, of course, you would have heard of OGC Web Services, and those are all the W*S, if you will, Web Map Service, WMS, Web Feature Service, Web Coverage Service. These are all established web services that every GIS in the world supports in getting things like maps and features. Features are things that have geometries associated with them that you can do spatial calculations on and the like. So this is a list of established standards, including Geography Markup Language, which is an encoding for that geography and the geometry that goes with it, the coordinate reference systems that go with all of that, and then KML. A couple years ago, Google came to us and said, we want to make KML an open standard. They contributed it to the OGC process. It's maintained now as an OGC standard in KML. Obviously, Google chairs that working group. Another area that's been established for a while is the sensor web enablement area. A few years ago, it was clear that there was going to be a lot of sensors that were networked enabled, that you'd be able to find sensors on the network that you'd never seen before, and you wanted to be able to discover what they did, be able to process, well, get that information and then process it, knowing enough about the sensor to be able to get good semantics and the like associated with that. So sensor model language describes sensors. Observations and measurements is a conceptual model for how you do an observation. It's consistent with the area of metrology, which is how you do scientific measurements and the like, and puts it in a framework of how to do observations, and then the services that go along with that. So these are relevant, both the OGC web services as well as the sensor web enablement. They're relevant to AR, I believe. In fact, we've seen a great demonstration by Mike the other day of there's a Willa client that gets after using several of these standards in an AR application. So you can make use of all the existing GIS information in the world in an AR framework using the web services and then the sensor web enablement. There's a few things that are more recent and are directly applicable, came from the first one in particular, ARML. Martin Lechner is going to talk in detail about that as the chairman of that working group, so I'll breeze over that. But we also have points of interest, indoor, sensor web for IoT, SMS, and GeoPackage that I'll speak a little bit more about here. So ARML2, really good stuff, descripting format, scripting, mobile visual AR. It's got some really good conceptual models that I think are informing the world from an abstract reference model framework of what it is, POI and Open POI. So points of interest and an implementation called Open POI. POI, if you're familiar with the W3C activity, it was started a couple of years ago now and then dwindled out. There was an activity to build a POI standard in W3C. Most of the intellectual energy associated with that project was provided by Raj Singh, Dr. Singh, who's on my staff, who did the model that's in that standard. Begged for help, so I think that's a good statement I can make. So, in any case, Raj Singh was a big part of that group. Obviously, it was a big group that did a lot of good work, but W3C decided they didn't want to carry it on. For us, it's a very important spec to have a geographic POI standard in the world. And so OGC now forming a standards working group to complete that work, publish the standard. This is all worked out with W3C management and everything, and we're going to continue that work. To support that, Raj has built the Open POI's registry of places in the world. So it's a registry of registries, if you will, and he's ingesting a lot of POIs into the Open POI database, and then publishing it out in this draft format. He's working OpenStreetMap the last couple of weeks. It's taken him a bit of time to ingest OSM. It's one of the larger repositories of POIs in the world. But you can go to that link and see different versions of the POIs coming out of Open POI registry. So you can go see that. I think that's relevant to AR. Indoor GML. So in fact, somebody mentioned you guys are doing indoor and AR together. So this week at Mobile World Congress, indoor, at least from my perspective, was the hugest thing, right? But maybe not for everybody. For me, it was huge. So there's like 6 or 8 different vendors that are doing, or developers that have an approach to indoor location, and mostly it's trying to solve some version of this problem. You've got a bunch of different radio signals that are bombarding your device. You've got other things that you can make use of, like sensors on the device that can do inertial guidance using accelerometers and gyros and barometers and all kinds of stuff. And so how do you use those to come up with where you're at indoors? What is the coordinate system that you're going to use indoors? Right now, most people are using lat long. I think most people don't think that's going to be the way it's universally done. And certainly as we get down to 1 meter accuracy and better, the existing WGS84 coordinate reference system is not good enough. WGS84 changes every 5 or 10 years. So the basis for the coordinate system changes every 5 years, and you can be off a meter or so based on having the wrong epoch of WGS84. And so, that's something to think about when you start doing indoor location. The part that OGC is really focused on is about modeling the space. So we're going to depend upon others to solve coming up with a location. We're going to work with those folks in terms of how to represent that location in terms of coordinate reference systems. but we're going to focus a lot more on modeling the space. The right side is the geometry and the uses of those spaces, whether they're hallways, elevators, the semantic use of that space that you assign to those geometries, as well as the overlay of all those radio signals that you saw, and they're not the same, right? So if you're in one room, you may be seeing a radio from another room, or if you see a radio, you could be in one or more rooms, right? You can't disambiguate where you're at from a location point of view just by looking at one signal. And so how do you put those together, and how do you navigate through that space is all what we call indoor GML is the name of the standard. It's a multi-layered space model, builds on existing standards, City GML and IFCs. And so this is a standard that's in work right now and should be published for public comment in the next couple of months, I think. I don't know if anybody remembers the schedule, but I think it's on that order. It's under work right now. So if you're interested in indoor, take a look at indoor GML. Sensor web for IoT. So we have an existing set of sensor web enablement standards for any kind of sensor, right? It was built to be very generic, and it was actually based on a NASA project that modeled space-based sensors, including hyperspectral and, big complex instruments. Well, maybe we don't need all that for IoT, Internet of Things. So we're taking those concepts that are in sensor web and putting them into an IoT framework. You've got this kind of situation in the marketplace right now where there's a bunch of IoT devices, and I think I have half of these. I've got a Kobayashi and a Nest, and they're great things, and I'd love to be able to talk more with them, but they all have their own, own application and protocols and the like, and they're silos, right? You can't talk to each other. So what we're working after is how do you get after an IoT service, an application level service that not only blends the different types of sensors, but then we're going to work with the various communities like OMA for mobile and Web3D and IETF to do that various communication layer. But the sensor model ought to be the same no matter what your underlying communications model is. So work together with folks and get a consistent semantics for sensors is what that's based upon the existing established SWE family of standards. Two more. Open GeoSMS. So it's exactly what you'd expect. It's the ability to send an SMS, but not just the text, but the text with a coordinate. So down there on the bottom, when you use Open GeoSMS, you end up with a coordinate. Essentially, you get the same text. You get a URL that includes a lat long and a tag that tells you it's a GeoSMS. And not only is it a location, but you can resolve that into a service that does something. Here, the example being a map. So if you click on that URL, it'll take you to the service, Google Maps, put you at that location, and show you the location. I lied. I have two more. 3D portrayal services. So this is one we worked together with the community. I need to mention the background as far as the interoperability experiment that we did, and involved a lot of different folks with a lot of different data, and two ways to do the client-server distribution of functions, if you will. It's all about how smart is your client versus how smart is your server, how much rendering is done on the server side versus how much rendering is done on the client side. So here you've got a scene graph. One approach is to pass the scene graph with a bunch of encodings and let the client figure it out. The other is to pass the images, have the rendering done on the server side, pass the images, and let the client essentially display it at that point. So where if you were tracking a little bit in the experiment, the interoperability experiment, these were two different discussion papers in OGC, one for the scene graph and one for the images. They've been combined now. So the approach with this portrayal standards working group that was formed in December is one standard will come out of that for both of those approaches. I would imagine there'll be different compliance paragraphs, so you can choose to implement one or the other, but they'll be in the same document. Last one, GeoPackage. So GeoPackage is a universal geodata file format. So a lot of energy around this one these days. So it is it's built on SQLite. So if you've got SQLite in your browser, and who doesn't? So it works on any desktop or mobile OS. but it's a way to package spatial information, whether it's features, imagery, or other information in a SQL-like suitable encoding, and then pull it into your mobile device. It'll replace things if you're familiar with GeoTIFF, SDTS, and shapefiles. It's how you get all of that good stuff. A lot of energy around that. Okay, so a lot of stuff. The existing web services and sensor web enablement that provides geographic, GIS kind of background feature data from all of the map providers around the world. All of your spatial data infrastructures can give you all of that geospatial information using web services, OGC web services, and then a set of new stuff, including ARML2. I think that's all I have, right?